everyone, thanks so much for joining me today. I have a great guest, and please, Luca, why don't you introduce yourself for those who don't know you?
All right. My name is Luca Pivano. I've been in the business for about 20 years, mainly working on simulation on dynamic positioning, so ranging from drilling to SOVs, shuttle tanker, and offshore vessels in general.
Yeah, I think we just had you on a session earlier today here at the show, and you were talking about the digital twin, and the first thing you opened with was answering kind of what is a digital twin. And I know that's a question that everyone is asking.
Sometimes it's a bit challenging to answer because a digital twin is basically a digital representation of your asset. It can be either the full vessel or a component or something, right? But there are so many different digital twins based on applications. For example, you can have a digital twin for predicting structural fatigue, and there is a digital twin that we're working on to predict the vessel performance, how the vessel moves in waves, if you can transfer people via gangway on SOV and things like that. There are some digital twins, for going in 3D modeling and exploring your vessel, get the manuals. There are some other for maintenance and condition system and things like that. So it's always somehow a challenge to explain what it is, and it's important to explain well what the application is, I think.
I know something we talk about is, like you said, there's no one digital twin. It's a series of them. So, but how do you share the information across them? How do you make sure they're connected, and how do you approach that kind of challenge in general?
Yeah, that's a good challenge. I think even in DNV, we offer different digital twins, right? So, and they don't talk to each other, but you could somehow extrapolate the data and show them as a sort of one overall digital twin with widgets and with visualization, but that comprises all the different digital twins and the results. But the actual mathematics, that they don't talk to each other, because you might think you put accelerometer on a ship for a structure, which it doesn't really matter compared to what the V control system does for keeping position, right? Or engine, how much fuel consumption engine uses, right?
So what are some of the challenges that your clients are coming to you with? What are you trying to solve from their perspective? What is the most important thing they're looking for?
Yeah, for on the design phase, is right sizing and basically comply to requirements, because sometimes at least today we have these requirements. I want my vessel to be transferring people 99% of the time during the year. How do you which thruster should I put on? Will the best design work with these thrusters, or if I use this thruster it will be better, worse, and things like that. In the operational phase, it's more about which power setups gives you better fuel consumption, for example. But at the same time, you want to maintain your managing your risk, because when you want to run, for example, with less engines, you need to run your power system as a one whole power system, right? So if something fails, you need to have this protective system that will kick in, right? So it's more risk, but then you have benefit of saving fuel. So yeah, so we find this balance between safety and efficiency in a way by running simulation.
Is that ultimately what it comes down to? Is cost and cost saving? Is that kind of the end goal at the end of the day?
Yeah, cost saving, but also risk management. Sometimes you might need to spend a bit more, but you need to be safe and secure what you're doing, right? Think about when you drill. If you lose position, you need to disconnect the riser, and then you might have all this spillage. This is not done properly, things like that. So it's a balance, really. Cost, benefit, and risk.
What are some of the upcoming things you're looking at for next year or the next 5 years, for example? What's kind of on the horizon for you?
When we look at digital twins, right, the ultimate goal is to sort of create a platform where different vendors, they put their own models. Because at the moment, I can model everything. I can model the thruster from shuttles, for example, right? But if they are their own models, which are more advanced than my model, it would be nice if they can plug in their model in our digital twin. And so the power system plugs in, the vendor plugs in their model and things like that. And what we're working on is that we need to have IPR protection, because if a vendor puts something on a platform, no one else should see what's inside their model, right? And so we are creating this, DNV has created this open simulation platform with all the partners, and a system on top of it, which is called the Simulation Trust Center, where if you put your model in our platform, I don't see what's inside the model, but that model can talk to our hydrodynamics.
Even you as DNV.
Yeah, correct. And then you can really simulate a lot of things with the best model you have. So this is sort of the next years, because at the moment the industry, I don't think is mature enough. Many don't have models yet. It will come, and we can have making these models as well.
Yeah. Excellent. Yeah, thank you so much, Luca. Thank you for joining me today. It's great to talk to you.
Thanks a lot.
Yeah, we'll keep up with you in the next couple of years and see how that goes.
Thanks a lot.
Yeah, thank you very much.